Hi, I'm Jack Harrington. I've been a React developer for the past 7 years, and I've been teaching it here on YouTube for the past 3. I'm going to give you my top 5 React do's and don'ts, and hopefully that should help you become a better React developer and JavaScript engineer in general. Let's get right into it. So let's start out with the do. Do use functional components, and by extension, don't use class components. I'm not sure why this is controversial now, but if you're still using class components or you're just starting out with React, I strongly recommend starting with functional components. Let me give you some reasons. Number one, functional components are the future of React. The only place you need to look is on their documentation site, where it's really hard, even now, to find a class component. And then on the new beta site, it's near impossible to find a class component. And it makes sense why, because number two, functional components have a much better state management mechanism than class-based components. Functional components use hooks, and those hooks create a reactive state management model baked right into React. Using useState and useReducer, you declare your state, and then using useEffect, useCallback, and useMemo, you react to changes in that state. And those 5 little hooks have created a vibrant ecosystem of super awesome hooks out there. There are hooks for getting access to your APIs, for doing external state management, for doing CSS, animations, everything you can possibly think of has a hook. And you don't get access to any of that if you're using class-based components. And then 3, and this may be counterintuitive, I guess, it's harder to build applications using function components and hooks. There's just a steeper learning curve. So if you start there, it's pretty easy actually to fall back onto class-based components if you end up being on a project that uses them. So if you're just starting out, or if you're currently using class-based components, I strongly recommend using function-based components. Next up, don't think about your React functional components as templates. I mean, they kind of look like templates. I mean, you imagine that this function generates some JSX, and then that's it. After that, the JSX or the hooks kind of run on their own. But thinking that way can be a cause of a lot of bugs. So let's go take a look at a piece of code that demonstrates this template thinking in action. So this is a user list, and its job is to go off and hit this API where we get a list of users and then display that list of users. So it's pretty simple. And let's just start out with our first render. We start out by defining some state. We got our list of users. That's good. And we started off with a empty array, which is great. And then we start our fetch to our API. And this is kind of where we get into trouble. Now, some folks think that what happens here is that the fetch blocks the rendering, that it's synchronous, that it won't render out the return until the fetch returns. But fetch is asynchronous, always has been, and always will be. So what really happens is the fetch goes off and starts doing its thing, and then we drop down into the return. Now here we have a div, and then we have a map inside there. We're going through the users, but we don't have any users because we just have that empty array. So we just return basically one div. Now eventually that API comes back to us, and we convert the payload from that using JSON into JavaScript objects, and then we set the users to those JavaScript objects. So far, so good. Now, template thinking would have us believe that there's some magic going on here, that by setting the users, this return section at the bottom is kind of run, I guess, by React on its own. There's sort of some sort of dynamic binding here, but that's not really the case. It's just a function, and just like any JavaScript function, when it re-renders, it just runs the function all the way from the start to the first return or the end of the function. So let's see what really happens. What really happens is we first run that use state and we get back the users. Awesome. Good job on us. And then we fire off another fetch back to that API. So now we make a second request, but we fall through to that return because the fetch is asynchronous, and we render our list of users. So it actually looks on the screen like we're doing well. We're actually putting up the users on the screen. But if we go over to the network tab, we can see chaos as we are repeatedly hitting that API user's endpoint because we've built ourselves an infinite loop. So what's really happening? Why is that happening? Well, on that second render, we get the response back from API users as we did before. We convert it from JSON like we did before. And then we set that users, which again instantiates a re-render. And you might be like, Jack, you're a liar, man. What's going to happen is that set users is going to look at those two arrays and it's going to see that the contents of those arrays are the same and it's just going to ignore it. But that's not what actually happens. A state setter is going to compare the old value with the new value using triple equals. Now, in the case of a number or a string or a Boolean, you're actually right. It's going to compare the value of those and not cause a re-render if the value is the same. But in the case of an array, like we have here, or an object or a function, it's going to compare by reference. And even though the contents of those arrays are the same, the references aren't. And so that's what that state setter is going to key off of. It's going to cause a re-render, and you're going to get the infinite loop. Of course, this is actually a pretty easy fix. All we need to do is wrap this fetch in a use effect and then give it an empty dependency array, which tells React that you're only going to ever run this use effect once on the mount of the component. So you can see how this template mindset gets you into some troubles and paints a false picture of how React works. So what is a good mindset when it comes to React functional components? Well, I offer this. So the top section up here, we'll call the hooks section. And then down here in the return, we call that the JSX section. And the rule is anything in that hook section should probably be wrapped in a hook unless you absolutely know otherwise that it shouldn't be. Next up, do use TypeScript when you're building out your React apps. I've heard a bunch of different objections to using TypeScript in React, and they usually boil down to one of three different objections. So let's go through them. The first one is that somehow TypeScript doesn't belong on the client, as if there's some exclusive enterprise club where you use strongly typed or typed languages like TypeScript. And that's just, I don't know. I can't even justify that. TypeScript helps you make more robust, more reliable, easier to maintain applications. So why wouldn't you want to use it in your React app? It has saved my butt so many times, and I've only been using it for the last 2-3 years. So it's absolutely worth using TypeScript in the applications. Objection number 2 is that somehow TypeScript bloats my code at runtime, which is absolutely untrue. And I think this comes from the idea that, say, we have a function and it's got an argument, and that argument is a person, and it should have a first name and a last name, and we put all that in the typing. And I think the idea is that TypeScript is going to somehow inject at runtime some validation that makes sure that the person has those fields in it. It totally doesn't do that. In fact, actually, sometimes I wish it would do that, and it doesn't. So it absolutely doesn't bloat your code. And then the third objection is something along the lines of TypeScript makes my code ugly. And okay, maybe that's got a point. And it's a subjective thing. I actually think TypeScript looks pretty good. But let's see if the value of TypeScript in a React app is worth the potential ugliness that you think might be in the code. So there are 2 times when TypeScript really genuinely touches a React app. The first is when you're defining your types, like the kind of data shapes that come back from the server. And the other time is when you're defining your React components. So let's take a look at both of those and see how TypeScript does. So we'll start off with defining your types. So here we're going to define the payload for a service that's returning a list of people. And it's got the URLs for the payload and the page size, and then an array of a person object that we define above that has all of the fields we expect in each one of the people that is returned from the server. And they have their types, their names. And what this allows us to do is anywhere we use that person, we can, 1, make sure that we get all the spellings of all the fields right. And if we change the fields, we change them all over the place, and we check all of that at build time to make sure that it's always correct, which is great. And the other thing is, check out that little question mark next to address. That tells TypeScript that address could potentially be null. So it needs to check everywhere we use address to make sure that we're checking for null. So say goodbye to those null dereference errors. So now let's look at typing a component. And we'll start by taking a JavaScript component and turning it into a TypeScript component. So here we have a myList, and that myList has two different props going to it. It's got the list, which is a list of people, and it's got an onClick, and that onClick is called whenever you click on one of those people, and it gives you a person as the first argument. And the JavaScript version has this as prop types. But here's the deal. Prop types are only checked at runtime, which means that in order to check to make sure that every single place myList is used, it's used appropriately, you're going to actually have to traverse through the entire application and watch all the console logs, which is not great. We want to get that done at build time. So what we're going to do is we're going to first define that myList is a React functional component. We do that by using react.js. And then within brackets, we say the props that we have. And that starts with list, where we define that as an array of persons. Pretty easy. And then we define our onClick. Now, if you remember from the prop types, the only thing we got to say was that it was a function. With TypeScript, we get to define what the argument is that goes to our callback, which is awesome. Because when you're using myList and you're putting an onClick on there, you get hinted about what's coming back and all the fields that are on that person. Super, super convenient and a much better way to define components. So now all we have to do is just get rid of the prop types, and we've converted to TypeScript. Not that bad and not that ugly. That's what I'm talking about. TypeScript is awesome, and you should definitely use it to build your React apps. This one's kind of a pet peeve for me. Don't worry about React re-renders too much. I can't go by like a week without seeing an article on how to avoid React re-renders, as if a React component rendering a second time is terrible and terrifying. And I'm not sure exactly where this comes from, but let's take a component like this title component, and it just takes a caption and it creates an H2. It's pretty simple stuff. And I think the idea is that somehow this component, the JSX in there, creates actual DOM nodes that then React takes and just smushes right into its DOM. That's not the way that React works. Let's take a look at the transpiled code here. So what's really happening is that we're just calling react.createElement. And you give it the type of the tag, you give it any properties, you give it the children, and then React makes a lightweight little data structure called a virtual DOM node. And then it takes that virtual DOM node and it adds it to the virtual DOM tree, which is an in-memory representation of what the actual DOM tree should look like. And then it's up to React to actually traverse that VDOM tree and then synchronize it with the real DOM tree. That's why it's called a VDOM framework. And it adds any nodes that it needs to add, and it deletes any nodes that it needs to delete, and it updates any nodes that are different than what's in the VDOM. But if there's no changes, then nothing happens. So I did a test a couple weeks back where I created a list, and that list had 500 names in it. Each one created its own div. And that first render, it was slow. It took 100 milliseconds to go and create those 500 divs. It's slow. But the second render, the re-render where nothing had changed, was sub-millisecond. So you don't need to worry about re-renders so much. In fact, if you're getting a lot of renders, it's probably just a bug. It's probably a use effect that has gone into an infinite loop because of a bad dependency array. But if you're legitimately seeing performance problems, there are a lot of tools baked right into React to help you diagnose and fix those performance problems. But my strong recommendation is don't fight the framework. Don't try to prematurely optimize your application by worrying so much about whether or not specific components are re-rendering. Do learn to love dependency arrays, or at least deal with them or not hate them quite so much. So dependency arrays are the arrays at the end of useEffect, useMemo, and useCallback. And they tell React when, for example, your effect should run. So if any of the items in that dependency array change, then your effect is rerun. And useEffect is the one that gives people the most grief. So let's take a look at a useEffect that goes off and gets some user data based on an ID. And at this point, that dependency array is empty, which means that if that ID was set to a valid user ID at the beginning, this is fine. It goes and gets the data. But if that ID was set to say null or something else, and that ID changes to another user ID, then this effect does not get rerun. So what we want to do is add anything that this effect is reading from and put that into the dependency array. So that's rule number one. In this case, that means that ID. But now you could say, well, why not just add everything in there? Let's go and add user and set user. Just to keep all our bases covered, right? But what you created doing that is an infinite loop, because in this case, once that fetch completes, you set user, which changes user, which again reruns that useEffect. So what we can do is we can add a conditional around that fetch to say, if we don't have a user currently, then run that fetch, if that's the logic that you're looking for. And that will make that use of the data that we've set in that useEffect safe, because now we've checked it and we make sure that we don't run into an infinite loop, which is something that happens a lot when it comes to useEffects. So rule number two, make sure that you check anything that you write in the useEffect when you add it to the dependency array. And then third, there's actually a lint rule that handles all this. And it's a great one. It comes right out of the box with React lint rules, and it tells you if you're missing any dependency arrays. And I gotta tell you, the number of times when folks have shown up on my Discord and shown some useEffect that's not firing or firing too much, and it's pretty clear that the lint rules would have picked that up, and you say, well, didn't the lint rules pick that up? And the person's like, I disabled that. This was too chirpy. Don't disable the lint rule. That's rule number 3. It's a great rule. I use it all the time, and I do React every day. So another thing to watch out for when it comes to dependency arrays is when you have an array or an object or a function in your dependency array. Because React uses the same logic that it uses in that state setter to decide whether the value is the same or different between the old value and the new value. And for strings and booleans and numbers, it does it by value, which is really predictable. But when it comes to arrays and objects and functions, it doesn't look at the contents. It does not do a deep compare like some people think it does. It instead does a referential compare. Is this exactly the same array? And I've seen lots of hacks around this. I've seen people go and do join, where they turn an array into a string, or they do a JSON stringify to turn it into a string to do kind of a deep clone and compare. But those are just hacks. Honestly, the best thing to do if you're running into reference issues around the arrays or objects or functions that you put into your dependency arrays is to go find where that array comes from and make sure that that reference doesn't change unless the underlying data changes. Next up, don't ignore useCallback or useMemo. Now, there was some advice that went around about how useCallback and useMemo impact the performance of a React app. That is absolutely untrue. They are vital to the reactive state management model of React. And when used properly to retain referential identity, they can be a performance enhancement to your application. So let's take a look at these two awesome hooks in isolation. And the first one we'll start off with is useMemo. Now, there are two reasons why you'd want to use useMemo. The first is if you are computing an array or an object, because those are maintained by reference, and you want to maintain that referential identity. And the second is if you are doing an operation that's going to be expensive. So let's go take a look at some possible uses of useMemo and see how they fall into our rules. This first one is calculating a total from a bunch of costs. So this is calculating a number, which doesn't fall into our first rule about an object or an array, but it could be a potentially costly operation because we don't know how big the cost array is. Okay, so there you go. It's a good use for useMemo. Now, the second example is where we have a list of people and we want to sort them. So we're creating an array, so it falls into our first rule, and we're doing a sort, which is potentially expensive, so it falls into our second rule as well. Now, our third example is far simpler. We're building a full name out of a conjunction of a first and a last name. And that's not good for either rule. One, you're building a string, so there's no referential identity problem. And two, just really easy to do. So there's no reason not to just turn this into a const right in line. Now let's talk about useCallback. So useCallback also is good in two cases. One is where you want to keep your callback functions from being stale. And two is when you want to retain the referential identity of those callbacks. So let's take this really cool name list component. It takes a list of names and it takes a sort function. And it does a useMemo the right way, actually. It's got the names and it's got the sort function in there. And it's only when those names or that sort function change that it's going to rerun that memo and do the sort. So it's really efficient. Anytime that you're going to rerun name list, it should not have to rerun that sort unless the names or that sort function have changed. So now I'm consuming this, and the way that I'm going to consume it is I'm going to invoke namelist, and then I'm going to give it my names, and I'm also going to give it a sort function, but I'm going to do it in line. And here's the gotcha. Every time my component re-renders, I create a new reference to a new version of that sort function. Now, the implementation is exactly the same every single time. But dependency arrays don't look at the implementation of a function, they look at the reference to the function. And so this is going to invalidate that useMemo. Now it's going to sort on every single render, even though names hasn't changed. The sort function has, so that's why the dependency arrays got tripped, and that's why the useMemo gets run. The way to get around this is to use useCallback and build the sort function that way. And then when I pass it on, I can be assured that every single time that I call that name list, I'm using exactly the same sort function, and therefore that useMemo will not be tripped. So as you can see, these are vitally important hooks that you should not ignore. So do make and use your own custom hooks. So custom hooks are collections of hooks gathered together as a function that accomplishes a specific task. And we are well on our way to making one of those over in our user list component, where we have our useState and our useEffect that work together to fetch data from that API and store it locally. So let's go and create our user list custom hook that has that useState and that useEffect in it, and then just return out the users. Now we can go use that in our component, but potentially we could reuse that in other components. And even better, we can test that userList custom hook in isolation, which is awesome. So custom hooks are a great way to get more reuse and build out a better factored and maintainable React application. Don't use Redux just because. When I first started over at Nike, all of our job recs were for React Redux developers, as if there were an absolute symbiosis between these two things. You couldn't do React without Redux. And even then, actually, that was not the case. You could use MobX or a bunch of different external state managers. But a couple of years back, when we got custom hooks and the reactive state model built into React, the idea of requiring effectively an external state manager like Redux didn't become as important, right? You can now go and use context and hooks to maintain state globally and closer to where you actually used it. So when you're thinking about building out your application and choosing your state management model, my recommendation to you is to start with using context and hooks and see how far that gets you. It may actually be enough. And if that's not enough, then you're probably going to be making some API requests, in which case you're going to be using something like React Query or SWR. And those are, in effect, state managers with their caches. So that might be enough, the combination of context plus React Query or SWR. And if you're doing forms, then Formic and React Hook Form, those also maintain state. So the combination of those things, all of those hooks, might be enough of a state management system for your application. But if that doesn't do it, of course, you could use Redux, although I strongly recommend using the Redux toolkit. If you do, it greatly simplifies the Redux development experience. Plus, it's got a fantastic query library built right into it, which is kind of the Redux analog of React Query. But there are also other ones. There's Recoil and Jotai, which are fantastic atomic state managers. And there's a new up and coming, very popular one called Zustand, if I'm getting the pronunciation on that one right. It is essentially kind of along the same model as Redux, just greatly simplified. So there are lots of options now when it comes to React state management. You don't need to go for Redux out of the box. But my number one suggestion to you is just keep it simple. Use as much as you need, but not anymore. And don't just use Redux because you think you need to use Redux. Speaking of query libraries, do use a query library. Use something like React Query or SWR. These are fantastic query libraries that do more than the happy path code that we created in our use user list, right? In our use user list, we don't look for any errors. We don't have any way to refetch stuff, any of that. React Query gives you all of that. It gives you the status code, gives you the errors, gives you ways to refetch stuff, gives you ways to refetch stuff on an interval. It's fantastic. It even has use mutation that makes it possible to go and do posts, and it's just super, super simple. So let me show you how we're going to go take our use user list and get it to use the use query hook from React Query. So first we import React Query, and then we're going to basically remove both the use state and the use effect and replace those with a use query where we give it the name of the cache, basically. In this case, it's going to be the users. And then we give it a function, and that function goes and does that fetch and goes and gets that data and then translates the response into JSON. So that's going to be our data that's coming out of our use query. And then we just return that as the data. But we get all of the advantages if we want to go and do things like refetch on an interval, all of those great features that are baked in to React Query. So my strong recommendation to you is if you plan on doing any kind of API access in your application is either use React Query or SWR or RTK, the React Redux toolkit and its query that's built in. These are phenomenal libraries, and you're doing yourself a big disservice by not using them or rolling your own. Here's one that's really near and dear to my heart. Don't build your own UI library. React has an amazing set of awesome React libraries. There's Material UI, there's Bootstrap, there's AntD, there's Chakra, there's Mantine. These are fantastic UI libraries that out of the box come with most of the controls that you're going to need to put on the page. Plus, they're accessible, they're internationalizable, they're themable, they're skinnable, they've got great documentation and examples and a whole user community around them that make it very easy to use them. Plus, and this is almost as important or more important, is many of these libraries, in particular like Material UI, come with templates for a lot of designers' favorite tools. For example, Figma. There's a Figma template for Material UI, and it's great. And what it does is it allows the designers to specify the UI, not just in kind of boxes and all of that with pixel sizes and whatnot and font sizes. It actually allows them to drag on components from Material UI and in fact theme it. And then when they give you those mockups, they're giving you exact callouts for those particular components with all of the props that you'll need. And it's just a much better way to communicate between the design team and the development team. And you lose all of that if you build your own UI framework. So please, please don't do that. So how'd I do? Did I get your do? Did I get your don't? Please let me know in the comment section down below. I really want to hear from you. I want to know what do's and don'ts you have to pass on to other React developers like myself. Of course, in the meantime, you should go and check out my Blue Collar Coder channel if you're interested in more videos like this. I'm working my way up to 100,000 subscribers, which is just a drop in the Brad Traversy bucket. Of course, In the meantime, thank you so much, Brad, for the opportunity to be here. I'll see you next time.